Welcome to the Connect with TrueSight webinar. During today's session, you will be able to ask questions of our panelists. The recording of today's webinar, as well as the Q&A, will be published to communities as well as the YouTube channel. At this time, we'll go ahead and get started on the TSOM application high availability best practices and troubleshooting, and I'll turn it over to Steve Mundy to take us through this content.
Thanks, Greg, and hello everyone. As mentioned, I'm Steve Mundy, a Principal Technical Support Analyst, and I've been at BMC for over 25 years, always working within customer support. To start off with, I'd like to set the scene. Working in customer support, I get to see a lot of different types of issues, and some of these are in the area of HA. These can be related to the HA implementation, configuration, or tuning, and on occasion, hardware issues. If you already run in application HA, are in the process of or thinking about implementing application HA, then this webinar is for you. In this webinar, I'll be looking at the TrueSight Operations Management Application High Availability for TrueSight Presentation Server, or TSPS for short, and TrueSight Infrastructure Management, or TSIM for short. We'll look at architecture and features before we dive into configuration, self-help, logs, common issues, and best practices. There'll be reference to primary server and secondary server, or active server and standby server. Both of these mean the same thing, as they're interchangeable. Please note that RSSO will not be discussed on this webinar. For those that are new to TSOM, or you just need a refresher, TSOM includes TrueSight Infrastructure Management Server and TrueSight Presentation Server. TSIM combines a number of things such as event management, service impact management, performance monitoring, and data analytics. TSPS is fed with data and events from the TSIM, as well as consuming data from other TrueSight products to provide a console for monitoring and administering the infrastructure. Here is a TSIM architecture slide, which encompasses a load balancer, primary and secondary server with Oracle backend database, receiving data from patrol agents via integration service. BMC does not provide load balancer software, and it must be a customer supplied load balancer. The load balancer routes requests to the active server. Deployment of TSIM and HA can only be done post-install via command pwha enable. The secondary TSIM will become the active server if the primary stops operating. Once the primary is started up again, it performs failback, becoming the active server, and the secondary goes back to standby mode. Please be aware that you can only deploy TSIM in application HA if using Oracle database, and Oracle RAC is recommended. If using SAP SQL Anywhere database, it is possible to achieve HA via OS clustering, but this is outside the scope of this webinar. This TSPS architecture slide encompasses a load balancer, primary and secondary server. The load balancer routes requests to the active server. Deployment of TSPS in HA can be done either at installation time or post-install via command TSSH HA configure. The secondary TSPS will become active if the primary stops operating. Once the primary is started up again, it does not automatically become the active server, but remains in standby mode until such time as the secondary is stopped. This is architecturally different to TSIM HA. Let's now look at some of the features with HA. With application redundancy, there is an automatic failover to the standby server if the primary has failed for whatever reason or has been stopped, such as for server maintenance. The difference between TSIM and TSPS is that for TSIM, there is automatic failback to primary server if the secondary server is active and then the primary server is started. For TSPS, there is no failback to primary server if the secondary server is active and the primary server is then started. For the TSPS primary server to become the active server again, the secondary will need to be stopped, thus allowing the primary to become active. And then once the primary is active, the secondary can be started again. Be aware that the TSIM and TSPS run in active-passive state and not active-active. Self-health monitoring includes self-shutdown for primary TSIM, which initiates failover, and restart for secondary TSIM if a critical process is down. For TSPS, regardless of primary or secondary, it will go for self-shutdown if a critical process is down. If there is a database connectivity issue that has lasted 15 minutes, the primary and secondary TSIM will go for self-shutdown. Critical events and email alerts are also generated as part of self-health monitoring. At startup, it checks last active node to ensure that nodes are restarted in the correct sequence, which prevents any data loss. This was added for TSIM in version 11.303. For TSPS, it has been available since version 11.301. This is the Skip HA check option that you may have seen when starting TSIM or TSPS. An important feature added in 11.303 is a check on TSIM server primary and secondary cells, which will alert if events or data in the MCDB are out of sync. It is the agent controller that does this check. There can be reasons why the cells go out of sync, such as recovering from a split brain condition, which is where both primary and secondary are active, or if the primary is restarted while the secondary is down. If the secondary is down for more than 6 hours, then once it is started, it requests the primary to transfer the MCDB across from automatically fixing the out of sync condition. We'll now look at some of the different configuration items starting with TSIM. It is very important for email alerts to be configured so that administrative type emails will be received. It can be done at installation time if this is a fresh install, as there is an option to be checked as shown here. Please be aware that if you're doing a fixed pack or service pack install, this option will not appear. If email alerts have not been configured at installation time, it can be done post-install by editing the files admin_user and from_name in the pw-etc host directory and editing pronet.conf in the pw custom conf directory, as shown here. The pw HA enable command is the only way to enable HA for TSIM. Once TSIM has been installed on both nodes, stop both the TSIMs and execute the command on the primary. It will create a file, ha-generated.conf, which will need to be copied to the secondary. Then on the secondary, execute pw HA enable command with the standby option and the file option referencing the location of the ha-generated.conf file. The secondary will then be reconfigured. To check the HA status on either node, the pw HA status command can be executed. The one on the left was executed on the primary, which was active, and the one on the right was run on the secondary, which was in standby. The ha.conf file located in the pw custom conf directory contains the HA configuration. The file contains various information, including host and port details for the components. We'll now look at some TSIM related parameters. The first parameter controls how often a check is made that a process is still running, and we can see the list of processes that are checked. This parameter has a default of 60. If a process is found to be unavailable, the scan is retried the number of times for the second parameter, which has a default of 6. This will prevent failover if there has been a temporary blip with a process on a scan cycle. If the process is still unavailable after the first parameter multiplied by the second parameter, then failover will occur. In certain situations, it may be necessary to change these parameters to prevent inadvertent failover, but this should only be made on the advice of BMC customer support. The action if any process is unavailable parameters control the action to take on the TSIM if a component has been deemed as unavailable, i.e. a TSIM process has gone down. The first parameter is now deprecated in version 11.303. For prior versions, it had a default value of shutdown. As soon as a process goes down on the primary, then the server is shut down, allowing the secondary to become active. The problem though is that if a process then went down on the secondary, then that TSIM will be shut down too. The parameter has been deprecated in version 11.303 and replaced with a new recovery action parameter. For primary TSIM, this still has a default of shutdown, but for secondary TSIM, it has a default of restart. This means that for the secondary, no matter the state of the server, standby or active, if a process goes down, then the TSIM will be automatically restarted. The federated cache parameter is the amount of time to wait for federated cache server to be unavailable before taking action, which for HA is to stop the server if it is primary or restart if it is secondary. This parameter has a default of 300 seconds. The federated cache server is housed within the agent controller process and is used by JServer and RAID processes. It is the JServer and RAID processes which both monitor the federated cache server. A split brain occurs when both primary and secondary are active. The prevention properties shown here are there to help avoid a split brain from occurring. By default, split brain prevention is enabled. The max retry property is the number of retries to check for the remote node status. If the remote node status is not identified as active within the number of retries, the current node becomes active. The scan frequency property is the number of seconds at which the remote node status is checked. The split brain recovery properties are for when a split brain has been detected. By default, split brain recovery is enabled. The notification support property is for event and email notification. The scan frequency property is the number of seconds that a split brain condition is checked. If a split brain is detected, the secondary will be restarted, forcing it into standby. With version 11.303, some new database connectivity parameters were added. Both of these parameters have a default of 15, and the connectivity check to the Oracle database is performed every 1 minute. The reason for having both parameters is that sometimes the check itself can take a couple of minutes if there is a database outage. A failure notification email is sent to the administrator every 2 minutes. If connection is re-established within 15 minutes, then a success notification email is sent to the administrator. If, however, after 15 minutes of no connectivity to the Oracle database, the TSIM server goes for self-shutdown. The behavior of versions prior to 11.303 is that retry will be performed for 3 times at 20-second intervals to connect to the Oracle database. A failure notification email is sent to the administrator every 15 minutes until TSIM is manually restarted. We will now move on to TSPS configuration items. Email alerts are not enabled by default. They will need to be enabled post-install by executing the TSSH properties set commands with appropriate values. They need to be executed on the TSPS node, which is active. If HA was not enabled at TSPS installation time, it can be enabled post-install with the TSSH HA configure command. Once TSPS has been installed on both nodes, stop both the TSPSs, start the database on the primary, and execute the command with the master option on the primary. It will reconfigure the primary and create a file, ha-share.conf, which will need to be copied to the secondary. Then on the secondary, execute the TSSH HA configure command again with the standby option, and when prompted, enter the path to the ha-share.conf file. The secondary will then be reconfigured, and the TSSH HA copy snapshot command will need to be executed manually before starting the secondary. Older versions of TSPS required the execution of command TSSH HA copy snapshot before starting the TSPS if it was not the last active node to copy the database from the other server. With TSPS version 10.7 and higher, it is no longer necessary to run that command, as the TSPS startup runs it automatically under the covers. As already mentioned, if configuring HA post-install, then the TSSH HA copy snapshot must be run on the secondary before starting it once it has been configured in HA. To check the HA status on either node, the TSSH HA status command can be executed. The one on the left was executed on the primary, which was active, and the one on the right was run on the secondary, which was in standby. All the HA configuration is stored in the ha.conf file, located in the TrueSight pserver custom HA directory. The file contains various information, including host and port details for the components. The node's persistent status parameters control whether or not the last node check occurs, and is there to prevent loss of data if both nodes are down and the last active node was not started first. Information is written to node status persistence.conf file on both nodes, which includes the status of the node and the timestamp of when the file was last updated. Node persistent status is enabled by default. The scan frequency in minutes property is how often the node status persistence.conf file is updated. The max downtime minutes property is the last active node startup time check in minutes. For example, if the node has been down for more than 45 minutes, then when it is started, you'll see the message at the bottom of the slide. The email support property is to send an email when the standby node is down, and the email frequency property is how often that email is sent. As already mentioned, a split brain occurs when both primary and secondary are active. The prevention properties shown here are there to help avoid a split brain from occurring. By default, split brain prevention is enabled. The max retry property is the number of retries to check for the remote node status. If the remote node status is not identified as active within the number of minutes of retries, the current node becomes active. The scan frequency property is the number of seconds at which the remote node status is checked. Split brain recovery properties are for when a split brain has been detected. By default, split brain recovery is enabled. The recovery action property is the action to be taken on the most recent active node if a split brain is detected. As it has a default of restart, then the last active node will be restarted. The other value that can be set for that property is stop. The notification support property is for event and email notification. The max retry count property is the number of retries to decide if a split brain has occurred. The scan frequency property is the number of seconds that a split brain condition is checked. The next few slides have example email alerts that are automatically sent. These are all from internal self-health monitoring, which is different to the monitoring provided by the self-health monitoring KM. The bold text at the top is the email subject, and the rest of the text is the email body. This email indicates that on TSIM 1, which is the primary server, it was detected that the rate process was unavailable for 7 scan cycles, and the TSIM has been shut down to allow the secondary to go from standby to active. TSIM 1, which is the primary server, has not been able to re-establish connectivity to the database for 15 minutes, and therefore the TSIM server has been shut down. This is a feature that we added in version 11.303. If database connectivity is re-established before the 15 minutes are up, then the TSIM server is not shut down. The same behavior occurs for the secondary TSIM 2, whereby it will also be shut down after 15 minutes of connectivity loss. This email tells us that TSIM 1, the primary server, was attempted to be started, whilst TSIM 2, the secondary server and last active node, was down. The action here is to start the TSIM 2 first, and once that is active, start TSIM 1. This is to prevent data loss. If it is not possible to start TSIM 2, then TSIM 1 will need to be started with the skip HA check option. Moving on to TSPS related self-health monitoring emails now, we can see that TSPS 1, the primary server, has been started, but because it has been down for more than 45 minutes, and TSPS 2, the secondary server, is also down, then a manual check needs to be made that TSPS 1 really is the last active node by checking the contents of file node status persistence.conf on both nodes. This is the type of email received when one of the nodes of the pair is down. It shows that TSPS2, the secondary node, is currently down. There could be a legitimate reason for this, such as server maintenance. We will now look at some of the log messages with regard to HA. For TSIM, all of these logs will be present in the PW Pronto logs directory. As the name suggests, the MCDB mismatch detect log contains messages related to the cell MCDB between primary and secondary being different. This log will only be present if you're on version 11.303, as this was a feature added in that version. The messages here indicate that primary cell has 32 events and 219 data instances, and that the secondary has 6 events and 15 data instances. A critical alarm event has been generated due to this mismatch still being present after 3 scan cycles. If a TSIM has been shut down by self-health monitoring, or restarted if it is secondary and the version is 11.303, the server component availability log will show which was the causal process that failed. Here we can see it was the cell process that was unavailable. The TrueSite log is the main log for TSIM. The first example shows that the cell process was unavailable and failover has been triggered by self-shutdown. The second example shows that the federated cache has been unavailable for more than 300 seconds and self-shutdown has occurred. The TrueSite HA runtime log contains general HA-related messages. This shows the same messages that would be emailed to the administrator and that an attempt was made to start this node whilst the other last active node is currently down. Moving on to TSPS logs now. These logs will be present in the TrueSite pserver logs directory. When TSPS is started, if the other node is active, it initiates a copy snapshot command under the covers to copy the database. If that fails, the db-remote-copy.log will show the reason. In this example, it is because the pg_hpa.conf file on the other node does not contain an entry for this node. As with TSIM, the main log for TSPS is TrueSite.log. The first example shows that the index server process is unavailable, and after 10 retries the TSPS is shut down, which causes the other server to become active. The second example indicates that the other TSPS node could still not be connected to after 5 attempts, and so this node will now become active. We will now take a look at TSIM and TSPS, both of which are running the latest version, which is 11.303. Starting off by going to the primary TSIM server, which is called TSIM1. Here is the install directory. We'll go to the pw custom conf directory, and there is the file ha.conf, which contains all the properties for the HA configuration. Here we can see such things as the Oracle database is rack or not. We can see cell port numbers, the name of the standby server, the name of the Oracle host, the name of the primary server, as well as port information. If we open a command window and execute pw HA status command, this provides details of the HA status of this particular server. All this information here is coming directly from that ha.conf file that we just looked at. The rest of the information here is coming from the cache. And you can see that this is the active node, how long it's been active, when failback last occurred, plus timestamps here, which are when the heartbeat signal was sent to those processes and when they responded. If we go to the secondary TSIM, run the same command, again, similar kind of output. All of this comes from the ha.conf file, but notice here that it now says node state of standby. Active is 0, last failover time is 0. So since this TSIM has been up, it has not actually been failed over to. And again at the bottom, this is the timestamp of when a heartbeat was sent to those processes and they responded. If we go back to the primary TSIM, execute pwpl command, which is process list. What we're going to do is we're going to kill the rate process, which will trigger failover. We can see here that the PID is 10064. Bring up Task Manager. It's the Java underscore rate process 10064. We've now killed that process. Execute pwpl command again. Shows us not running. We go to the pw pronto logs directory. The first one we will look at is server component availability.log. Go to the end of the file. So since we've killed that process, no messages have been written. So it hasn't got round to doing the scan cycle that checks the processes are available. If you recall, the scan cycle occurs every 60 seconds. So let's just pause for a minute or two and wait for this log to be updated. The log has just been updated and we can see here the message saying that rate process is unavailable for one time. The next message will be written in about 60 seconds time. And here we can see 60 seconds later it reported that it was unavailable for 2 times. If we open the truesite.log, which is another very good log to look at, go to the end of the file, you will see similar messages that you see in server component availability log. So here you can see it's unavailable for once, twice, and now 3 times. We'll leave this a few minutes and then we'll check the logs again and see what messages have been written. Log has been updated. Let's reload it. It's now shown it's been unavailable for 5 times. The max retry count for the scan is 6. So after that, it will then perform one more scan check, and then if the process is still unavailable, it will go for self-shutdown. So let's just give this a couple more minutes and wait for that to occur. Just reload the file. So it did the 6th scan, then it did one more after that. Process still unavailable, it's gone for self-shutdown. Email sent to the administrator. Message to confirm that it's triggering failover. Go to server component availability log. Similar messages there. If we execute the pwpl command again, they've all been stopped. Execute pwha status. So all these details here show as unknown because the TSIM server is down. If we go across to the secondary TSIM now, TSIM2, PWPL command, processes are running, PWHA status command, notice it still shows as standby. This is because it will still take a few minutes for this secondary to become active. If we go to the PW Pronto logs directory, TrueSite.log, you can see here messages that it's not been able to communicate to the primary TSIM. So that was the point at which that primary TSIM was stopped when it went for self-shutdown. So the secondary will do a check for a few cycles. If the primary TSIM is still deemed as being down and unconnectable, then this secondary TSIM will start to become active. Just reload the log. So it went round and checked 6 times, still couldn't connect. So this is the key message here. Got the leadership lock, this node will be considered as active node in the cluster. And then this one here, I'm going to become active. So from this point onwards, this TSIM is going to go from standby to active. And it will take a few minutes for this TSIM to become up. And that's because it has to do an internal restart under the covers so that all the processes come up clean and reload their cache. If we execute the PWHA status command again, notice it now shows node state unknown because it's in the process of coming up. If we execute PW license list command, it shows us failed to connect to server, and this is because of the internal restart that's done. We'll just wait a few minutes for this to become fully up. Reload the log to check the latest messages. Execute the PWHA status command again. Now shows as active. Active since this time. This is when the last failover was. Timestamps are the heartbeats to these processes. So this node is now up. If we check the PW license list command again, and here we've got a good response, which is again is more confirmation that this server is up. As this is now the active node, we can now go ahead and start the primary TSIM up. By executing the command pw sysstart. We'll leave this to come up and we'll take a look at TSPS now. This is my primary TSPS. It's called TSPS1. If we execute the TSPS HA status command, gives us a state of this server. We can see here that this is active, how long it's actually been active. This is the FQDN of the server, tsps1.bmc.com, and this is the FQDN of the secondary, tsps2.bmc.com. And at the bottom here is my load balancer name, tsps.bmc.com. From the installation directory, we'll go to TrueSite pserver conf HA directory, and here we have the ha.conf file. which is a configuration file, which shows us port and host information. Also in this directory is the node status persistence.conf file. Shows that the node is active, timestamp of when this file was last updated, status of the remote node. If we move on to the secondary TSPS, TSPS2, check the status by running the TSPS HA status command. It shows us standby. Again, details of the nodes and load balancer name. Going to the TrueSite P server conf HA directory, that's your ha.conf, node status persistence file. Shows that this node is standby. When this file was last updated, status of the other node. What we'll now do is go back to TSPS1. We will kill a process which will trigger failover. Execute TSSH server status command. These are the processes and the corresponding PIDs. We'll kill the index server process, which is PID 1208. Repeat the command. Shows us not running. Go to TrueSite P server logs. Open up the TrueSite.log file. Go to the end of the file. And here we can see messages here corresponding to the index server process. The scan cycle here is every 10 seconds for the process. And it will go up to maximum of 10 times of it being unavailable before it goes for self-shutdown. So let's just give it a couple more minutes and then we'll check the log again. A couple of minutes have passed, so let's go and reload this log. Checked it was unavailable for up to 10 times and has now shut down. Run the TSSH server status command. No processes are running. If we go over to TSPS2 now, run the TSSH HA status command. Still shows it's in standby, so it will be coming up shortly from standby. Let's take a look at the TrueSite.log on this server now. TrueSite P server logs directory. TrueSite.log. End of the file. So here is a message indicating that it can't connect to the primary TSPS, TSPS1. And it makes a few attempts at trying to check that connectivity. Here we can see we're up at attempt number 3 to reconnect. Reload the log. Now at attempt number 4. So let's give it a minute or two and then check this log again. Just reload the log. Attempt number 5. Tried 5 times, the remote node is not active. Acquiring the lock, processing with the leader request. So this is the message to indicate that this is now becoming active. So we'll just give it a few minutes for it to become fully active and then we'll check the status. Reload the log. execute TSPS HA status command. This node is now active. And what we can do at this point is we can now start the primary TSPS up again. Starting the primary here with the TSSH server start command. And here the message indicates that it's checked the status of the other node's up and is active. It's copying the database across. It's done that. TSSH server status. Processes are up and running. TSSH HA status. Hasn't fully initialized yet, which is why we get this connection refused message. So let's just give it a couple of minutes more for this to come up. Execute the command again. Shows that this node is standby, which is correct. And if you recall, this is architecturally different to TSIM. If you want this node to become the active node, it will be necessary to stop the other node first, so that failover can occur to this. Then once this has become active, you'd start the other node up again. That concludes TSPS. If we just have a quick look now at the TSIM, which we started, PWHA status, it shows that it's still in the process of initializing. And it will take a few minutes for this to come up. That concludes this demo, so now back to the slides. Let's now take a look at some of the common issues that have been seen with application HA. A split brain occurs when the HA nodes can no longer communicate with each other, as each node assumes the other one is down and you end up with both primary and secondary being active. A cause of a split brain could be a network outage or ports blocked in a firewall. With version 11.302, we introduced new commands, PW System Port Check for TSIM and TSSH Component Port Check for TSPS that can be used to test port connectivity. If you're on a version less than 11.302, Knowledge Article 000158447 contains a utility that can be used to check port connectivity. You may have seen an error that you are accessing a standby system when logging into TSIM or TSPS. This is typically caused by a misconfigured load balancer, which is still routing traffic to the standby node rather than the active node. Though it is also possible to see this if one node is down and the other node is in the process of going from standby to active. Try to log in with the server hostname rather than the load balancer name. Check the load balancer for any misconfiguration. Run the HA status command to verify the state of the node. If there is any type of instability with TSIM or TSPS, then it may be due to misconfiguration. Run the health check tool and make changes as per the generated report for any item which shows as critical, error, or warning. During a large publish, the cell could become busy whilst it uploads the service model. The process check believes that the cell is down rather than busy, and a failover to secondary occurs. We have made changes in version 11.303 so that the cell no longer appears as down by the process check during a large publish, which will prevent inadvertent failover. If it is not possible to upgrade to 11.303, then try to publish in smaller chunks or increase the max retry count parameter, but only on advice of BMC customer support. For TSIM, the Skip HA check option was added in version 11.303 to prevent data loss due to not starting the last active node first. If the certificate for primary server is not installed on the secondary server or vice versa, this can cause TSIM to fail at startup unless the Skip HA check option is used. Execute the command shown here, and if it shows PKIX error, it confirms a certificate issue. Alternatively, run the health check tool and look for the line Web Services Communication in the generated report. We will now take a look at the Web Services Communication section in the health check tool. Go into my primary TSIM, run pwha status command. It confirms this is the active node. My other TSIM, TSIM2, is currently in standby. I'll go to the install directory, program files, BMC software, TrueSite, utility. I have already downloaded the latest version of the health check tool, which is 2.2, placed it in this location as per the health check tool readme. Open a command prompt here and execute the script TrueSite health check. This may take up to a couple of minutes to execute. If we cross over to the secondary TSIM, TSIM2, pwha status, shows this is in standby. I had already run the health check tool earlier on this machine. If we just have a look at the output, so this is the report that is generated in HTML format, and this is the section here to do web services communication. It had a HTTP code 200, which is an acceptable response. Remember that it isn't checking the HTTP response on this node that the health check tool is run on. It's checking the HTTP response of the other node in the HA pair, and a 200 is to be expected because 200 is what is returned from the active node. So that all looks fine. If we cross over to TSIM1 again, health check tool was completed. Step 9 here is the section to do the web services check. This message here is the report that was generated and the location. If we have a look at that report, web services communication, here it is, it had a 503. And again, it explains that that is expected response of a standby TSIM. I will now stop the secondary TSIM server. pwsys stop command. That's now executed. Server is stopped. Cross back over to TSIM1. Execute the health check tool one more time, and then we'll check the output. This is now executed. This is the newly generated report. We'll open that. And here is the web services communication section. There is a -1 HTTP code, which is an error condition. It mentions here possible causes for this condition. We'll now take a look at TSPS. This is no TSPS1. Execute TSSH HA status. Shows it's a standby of the pair. Again, I ran the health check tool earlier on this node. Have a look at the output. Here is the section here, web services communication. Return code 200. Remember again, that is the HTTP code of the other node of the HA pair, and that is an acceptable response because that other node is active. If we go over to TSPS2, shows it's active. I will now run the health check tool on this server. Go to the install directory, utility, TrueSight Health Check, open a command window here, execute the script TrueSight Health Check, and give it a couple of minutes to execute. It has now executed. Check the report. Web Services Communications section is here. HTTP code 502, which is expected because the other TSPS in the HA pair is currently in standby. We'll go back to TSPS 1, which is the standby node, and we will stop it. TSSH server stop. Go back to TSPS 2, run the health check tool one more time. The tool has now completed. Let's check the report that's been generated. And here we have the web services communication line here, and it's showing a -1 because the other node is down. And again, possible reasons why, as well as mention of a knowledge article. The patrol repository containing KMs and solutions is not automatically replicated between the TSPS servers. If you import a solution into the repository and then fail over to the other node, that solution will not be visible. The repository will need to be manually copied from one server to the other so they are the same. After the secondary TSIM has become active, if you see such things as events of class MC cell undefined class, custom rules not running as expected, or events with MC bad slots rather than slot name, then this indicates that the cell knowledge base on the secondary is not in sync with the primary. The cell KB is not automatically replicated between the TSIM servers. Any changes to the primary cell KB, such as for class definitions or rules, will also need to be made to the secondary cell KB. We will now go through some of the best practices for HA. If the secondary TSIM is down for whatever reason, and the primary TSIM is restarted, it will result in a cell MCDB out of sync situation, and the cell MCDB will need to be manually synced before the secondary is started. If the secondary TSIM is down for a period of time, then it may cause the cell on primary TSIM to become unresponsive, as it keeps trying to resend messages to the secondary cell. This in turn can cause the primary TSIM to be shut down. Changes have been made in version 11.303 so that the cell will still be responsive if the secondary is down. If you are not on version 11.303 and need to keep the secondary TSIM stopped for whatever reason, then at the very least just make sure the cell is running. Configure both TSIM and TSPS so that the administrator will receive the self-health monitoring email alerts. Make sure the email does not go to junk folder. I cannot stress enough the importance of configuring for email alerts. Always follow the product documentation. You might be a seasoned professional very familiar in TrueSight, but we do change our documentation from time to time. For example, with version 11.303, we made changes to the instructions for installing a service pack on TSIM to prevent any data loss. There was a recent webinar on the health check tool which is worth watching if you're not familiar with the tool. It is really important to execute this tool and resolve any type of misconfiguration. Version 11.303 of TSIM and TSPS ship with version 2.0 of the health check tool. Updates to the tool are made outside of the release cycle, so always check the knowledge article or FTP site for latest version. An important point to also make is that with the latest version of the tool, version 2.2, for both TSIM and TSPS HA, it performs the same web services calls that the servers make at startup to verify it can connect to the other node. That is a good way of checking there are no issues with the TSIM and TSPS servers talking to each other. As with every major release and fixed pack or service pack, we make changes to improve HA stability. You should aim to be on version 11.303 as that is the latest version, and as we saw in earlier slides, includes check for TSOM CDB out of sync, last active no check for TSIM, and self-shutdown if loss of connection to Oracle database. This references slide has links for troubleshooting HA issues and contains some additional information above what has been covered in this webinar. There is also the link for the Health Check Tool webinar. In summary, we covered the features of HA, which includes application redundancy, self-health monitoring, and new features added in version 11.303. For configuration, we looked at the key parameters, how to set up email alerts, and the commands to configure HA and check the status. Various example emails were included to further enforce the importance of having email alerts configured. The key log files were included and messages showing specific problems. Some of the common support issues that customers have faced were covered, as well as best practices. And that concludes my presentation, so I'll hand you back over to Greg.
Thank you, Steve. And now I will take us through the self-help and contacting BMC. This webinar is available on our YouTube channel, along with a rich set of how-to videos. Also, the Connect with TrueSight webinar schedule for future as well as past webinars is available at this community's link. And for contacting technical support through web, phone, or email, as well as these social channels are listed here. I want to thank you for attending today's webinar. And again, the webinar and Q&A will be posted to communities and our YouTube channel a week from today's live viewing. Thank you.